You might have heard of the basic machine elements. There are 6 basic machine elements: the lever, the inclined plane, the wedge, the screw, the wheel and axle, and the pulley. A pulley is kind of a useful device. It can do a couple of things. It can change direction for you. So if you want to lift something but you'd rather pull down, you can use a pulley to do that. Or what's really cool, it can multiply a force for you. So let's go look at how that works. And if you've been to OMSI up in Portland, you might have played in this physics lab, I know I did, where they had some old weights from a gym hooked onto some ropes, and some of them have pulleys with multiple ropes. And you can pull on them and feel that, okay, with just one rope, it's heavy. With 2 ropes going around a pulley, it's half as heavy. With 4 ropes going around pulleys, it's a quarter as heavy, but you have to pull out 4 times as much rope, and you can feel it right there. Let's sneak up on this. So we'll start with a box. The box weighs 600 pounds, and it's hanging from 2 ropes. No pulleys yet, just hanging. So if there are 2 ropes, how much tension is in each rope? Well, it must be split half and half, right? Half the tension in one rope, half the tension in the other rope. So there must be 600 pounds of tension in each rope. Okay, now let's insert a pulley in there. We still have 600 pounds pulling down, and we still have 2 ropes pulling up, and there's still half the load in each rope, so each rope must feel each piece of rope, I should say, must feel 300 pounds. So the pulley doesn't really do anything, it's just the rope is going around it. And if you want to, you could attach yourself to one end of the rope and use it to pull up that box. And we still have 2 pieces of rope, so the 600 pounds is split equally among those 2 pieces of rope. 300 pounds on one side, 300 pounds on the other side, where you are pulling. So you can pull with 300 pounds of pull and lift 600 pounds of weight. But think about the distance you've got to cover. Let's say you want to lift that box 5 feet. Well, if you want to lift it 5 feet, the rope on this side has to shorten 5 feet, and the rope on that side has to shorten 5 feet. So we've got a total of 10 feet of rope that have to go through that pulley in order to make the thing rise 5 feet. So what we see here is there are 2 pieces of rope attached to the movable pulley. That means we have a 2-to-1 advantage. We can lift with half the force, but we're going to pull twice as much rope through. Now, if you'd rather pull down, you can swing the rope up over a pulley up on the ceiling, but you've still only got 2 pieces of rope attached to the movable pulley, so you've still only got 300 pounds on each piece of rope. That pulley up on the ceiling didn't do anything for you except change direction, so you could pull a different direction. It's the pieces of rope on the movable pulley that make the difference. And you're still going to have to pull twice as much rope through in order to lift it. Now, here's a pulley that has 3 pieces of rope on it, on the movable pulley. So 600 pounds pulling down, a third of that, 200 pounds on each of the 3 ropes, even though you can see some of them go around the outside and some of them connect to the middle. That doesn't matter. We've got 3 pieces of rope, so we need 1/3 the force. But we're going to have to pull 3 times as much rope length. Here's an even fancier one. These 3 pulleys are all movable, aren't they? They're all attached to the load and they're all going to be moving up. And it doesn't matter that some of the rope is on the outside of the pulley and some of these are attached in the middles of the pulley. There are 6 parts of rope on the movable pulleys. So that means you can lift this weight with only 1/6 the effort. You could pull with 100 pounds of pull and lift that 600-pound weight, but you are going to have to pull 6 times as much rope length through the thing. So the whole key to the deal is to look at the movable pulley and to count how many parts of rope are on the movable pulley. In this example, there are 2 parts of rope on the movable pulley, so you've got a 2-to-1 advantage. Same with this one, 2 parts of rope on the movable pulley, you've got a 2-to-1 advantage. This thing up at the top doesn't do anything but change direction. You've heard people talk about block and tackle, maybe. A block is this pulley, or could be a set of pulleys. That's a block. A tackle is a block with rope or cable going through it. So when you say block and tackle, what you mean is you've got some pulleys with some rope or some cable going through them. And then here's this word reeve that you don't hear very often, but reeving means to pull the rope or the cable through the block. Okay, so this book is showing us 2 parts of rope on the movable pulley. We've got a 2-to-1 advantage. And on the right, 1, 2, 3 parts of rope on the movable pulley. We've got a 3-to-1 advantage. Here we are illustrating that again. 2-to-1, 3-to-1 advantage. People who do crane design and rigging design and engineers sometimes make these diagrams where they spread the pulleys out as if they were lined up in a row. I find that a little confusing at first, but that's what the diagram looks like. So here's what the actual block and tackle looks like with, look, 1, 2, 3, 4 parts of rope on the movable pulley, so a 4-to-1 advantage. Here's the reeving diagram. Here's another reeving diagram for a 4-to-1 advantage. Here's one out of a crane design book that they are showing in isometric view. This is out of a mechanical design engineering book, and so at the top are some pulleys with a rope pulling downward, and at the bottom are the same pulleys with the rope pulling upward. And then he's showing us how many parts of rope on the movable pulley. That's the mechanical advantage. That's all this is saying. This is out of a kid's book. I really like kids' books because they have good pictures for illustrating stuff. So here they were illustrating how you could put a spring scale in the rope that you were pulling on so that you could see how much force you were pulling with. And so here we have, this one is metric, a 10 Newton weight with 10 Newtons of pull. But if you put the rope around a pulley, so you have 2 parts of rope, now you read only 5 Newtons of pull. And if you put 4 parts of rope on a movable pulley, you read only 1/4 as much, 2.5 Newtons of pull. Here's one out of one of my favorite kinds of books is the Naval training manuals. They're really good at explaining things in simple ways, usually. So here they're showing a pulley with 3 parts of rope attached to the movable pulley. And never mind what's happening up here or what direction the pulling is going. Here's the movable pulley, 1, 2, 3 parts of rope, 3-to-1 advantage. Here's another one out of a naval training manual illustrating how you can get a 12-to-1 mechanical advantage. You can lift 1,200 pounds, by pulling with only 100 pounds of pull. So we'll look at the right side first. 1,200 pounds of weight. There are 1, 2, 3 parts of rope on the movable pulley. So we get to divide the weight by 3. So there are only 1,200 divided by 3, 400 pounds of weight on each of those 3 ropes. One of the ropes is changing direction. It's going up and around this pulley up at the top, and so it's still got 400 pounds as it's coming out. 400 pounds as it's coming out. And now we have 1, 2, 3, 4 parts of rope on the movable pulley. 4 to 1 advantage, 400 on one side, 1/4 as much on the other side, 100 pounds of pull in each rope. So you could pull with 100 pounds of pull on this rope and lift a 1,200 pound weight. In your quiz, there are 2 sets of pulleys. It's a short quiz. And in this one, you need to look and see how many parts of rope are on the movable pulley. So once again, we don't care about the one at the ceiling. We just go 1, 2. In this problem, we want to know how many parts of rope on the movable pulleys. And never mind all this gobbledygook up at the top here. These 2 pulleys at the bottom are the ones that are moving. And what have we got? 1, 2, 3, 4, 5. We've got 5 parts of rope, so we're going to have a 5 to 1 advantage, but we're going to have to pull 5 times as much rope length.